This is a guided walkthrough for day number 21 from the Advent of Cyber event from TryHackMe. This is TryHackMe Advent of Cyber 2024, and the topic is reverse engineering, and the title of the challenge is called Help Me, I'm Reverse Engineering. All right, so let's read a little bit about the challenge before we get started. MixKitty's alert dashboard lit up with an unusual alert. A file sharing web application built by Glitch had triggered a security warning. Glitch had been working hard during this season's sock miss after the last scare with the Yule log exploit, but this new alert caused MixKitty to question his intentions. MixKitty began to investigate. It seemed the source of the alert came from a binary file that made its way to the web app's backend. It did not belong there and had some anomalous activity. The binary was compiled with .NET. This whole setup seemed quite unusual, and with Glitch working on the latest security updates, MixKitty was filled with suspicion. As MixKitty continued her investigation, Glitch rushed into the room. I swear I did not put it there. I was testing defenses, but I wouldn't go that far. MixKitty reassured him. This doesn't look like your work. Let's get to the bottom of this. Put on your decompiling hat, and let's see what we're dealing with. Okay, so on to today's learning objectives. Today we're going to understand the structure of a binary file and understand the difference between disassembling versus decompiling. We're going to become familiar with multi-stage binaries, and we're going to practically reverse a multi-stage binary. All right, so let's continue on to connecting to the machine. So before moving forward, we're going to take a look at what we need to do to complete today's machine. Do I need to start the attack box today? Yes. Do I need to start a VM today? Yes. Is there split screen available? Yes. Am I given credentials to connect directly to the VM via RDP, VNC, or SSH? Yes. Okay, so I think you actually do not need to log into your attack box today. But we can click on this green Start Machine button to start up the process of spinning up the virtual machine that we're going to be using today. So the virtual machine is going to take a couple of minutes to initialize. In the meantime, what we can do is we can go ahead and read on and see what we're going to be dealing with today. So we're going to be doing an introduction to reverse engineering. Reverse engineering, sometimes called RE, is the process of breaking something down to understand its function. In cybersecurity, reverse engineering is used to analyze how applications, binaries, function. This can be used to determine whether or not the application is malicious or not, or if there's any security bugs present. For example, cybersecurity analysts reverse engineer malicious applications distributed by attackers to understand if there is any attributable indicators to associate the binary with an attacker and any potential ways to defend against the malicious binary. A famous example of this is the WannaCry ransomware in May of 2017. Security researcher Marcus Hutchins reverse engineered the ransomware application and discovered a specific function within the application where the malware wouldn't run if a particular domain was registered and available. Marcus then registered this domain, stopping the global WannaCry attack. This is just one of many famous cases of reverse engineering being used by cybersecurity defense. Binaries. In computing, binaries are files compiled from source code. For example, you run a binary when launching an executable file on your computer. At one point in time, this application would have been programmed in a programming language such as C#. It is then compiled, and the compiler translates the code into machine instructions. Binaries have a specific structure depending on the operating system they are designed to run. For example, the Windows binaries follow the portable executable or PE structure, whereas on Linux, binaries follow the executable and linkable format, ELF. This is why, for example, you cannot run an .exe file on Mac OS. With that said, all binaries will contain at least A code section. This section contains the instructions that the CPU will execute. A data section. This section contains information such as variables, resources, images and other data, etc. And import-export tables. These tables reference additional libraries used or imported or exported by the binary. Binaries often rely on libraries to perform functions. For example, interacting with the Windows API to manipulate files. The binaries in today's task follow the PE structure. This structure will be explained throughout the task. Disassembly versus decompiling. When reverse engineering binaries, you will employ two primary techniques. This task section will introduce you to disassembly and decompiling, explaining the key differences and their pros and cons. Disassembling a binary shows the low-level machine instructions that the binary will perform. You may know this as assembly. Because the output is translated machine instructions, you will see a detailed view of how the binary will interact with the system at what stage. Tools such as IDA, Ghidra, and GDB can do this. Decompiling, however, converts the binary into its high-level code. Decompiling, however, converts the binary into its high-level code, such as C++, C#, etc., making it easier to read. However, this translation can often lose information, such as variable names. This method of reverse engineering a binary is useful if you want to get a high-level understanding of an application's flow. There are specific circumstances where you would choose one method over the other. For example, decompiling is sometimes a best guess based on the tooling you've used and does not provide the actual full source code. A table outlining the key differences between the two has been provided below. Okay, so readability in disassembly requires knowing assembly and low-level knowledge of computing concepts, whereas in decompiling, it requires familiarity with programming and logic. So the level of output for disassembly is translated outputs in the exact instructions that the machine will perform, but in decompiling, the translated output is a best guess. The output may not be accurate, and useful information such as variables, function names will likely to be lost. The difficulty, on the other hand, for disassembly is considered higher as machine instructions are translated into assembly, whereas decompiling, machine instructions are translated into high-level language, which makes them easier to understand if you're familiar with the language that the binary is written in. And lastly, usefulness. For disassembly, the entire behavior of the binary can be studied given enough time, whereas in decompiling, it's a quick way to understand some of the logic of the binary. So let's talk a little bit about multi-stage binaries. Recent trends in cybersecurity have seen the rise of attackers using what's known as multi-stage binaries in their campaigns, especially malware. These attacks involve using multiple binaries responsible for different actions rather than one performing the entire attack. Usually, an attack involving various binaries will look like the following. Stage 1, Dropper. This binary is usually a lightweight, basic binary responsible for actions such as enumerating the operating system to see if the payload will work. Once certain conditions are verified, the binary will download the second, much more malicious binary from the attacker's infrastructure. Stage 2, Payload. This binary is the meat and bones of the attack. For example, in the event of ransomware, this payload will encrypt and exfiltrate the data. Sophisticated attackers may further split actions of the actual chain, for example, lateral movement, into additional binaries. Using multiple stages helps evade detection and makes the analysis process more difficult. For example, a small, more harmless initial binary is likely to evade detection by email filtering rather than a fully fledged binary that performs malicious actions such as encryption. Additionally, splitting these functions into multiple stages gives the attacker much more control, that is, only downloading specific stages once conditions such as time have been met. The diagram below shows what an attack involving multiple stage binaries may look like. Okay, so we've got the first stage over here, where we might have a phishing email or an compromised site, which leads to these initial dropper files being placed on the victim's machine, such as a doc file, a PDF file, or an RTF file. And these files are going to execute the second stage. And the second stage is going to be a JS file or a PS file, which is going to download something from the web and then download and execute either an exe file or a DLL file, which is the actual malware. So a lightweight first stage and a more heavy and meaty second stage. Jingle.net all the way. For today's task, we will be reverse engineering two .NET binaries using the decompiler ilspy. You can follow the walkthrough below in reverse engineering using an example application named demo.exe. Then you will reverse an application on your own at the end of this task. Before analyzing our target, we need to learn and find a way to identify the original binary file, modify it, or use it as evidence. Also, it is a good practice to have a big picture of the file we are dealing with so that we can choose the proper tools we will need. Let's start by navigating to the file location in the demo folder on the machine's desktop by right-clicking on the file demo and clicking on properties. Okay, so we can do this ourselves. So we've got our demo folder over here. We're going to open that up. And then inside, there's the demo binary over here. We're going to right-click on it. And then we're going to click on the properties button over here. Okay, and then we have a little window. We can observe that the file's extension is exe, indicating that it is a Windows executable. Okay, so over here it says exe, so it's a Windows executable. Okay. Since it is a Windows file, we'll use PE Studio, a software designed to investigate potentially malicious files and extract information from them without execution. This will help us focus on the static analysis side of the investigation. Let's open PE Studio from the taskbar and then click on File Open and select the file demo.exe located in this folder over here as shown below. Okay, so we can click out of here and then we can close out this folder and then we can click on this PE Studio shortcut on the desktop. So just double click that. Okay, so I'm going to make this a little bit bigger for us. And then in Files, we're going to open the file. And we're going to open up Desktop, and then Demo, and then this demo file over here. Select it, and then click on the Open button over here. Okay, so we've got a bunch of different information here. As shown below, PE Studio will display information about the file, so let's start enumerating some of the most important aspects we can get from it. Using the left panel, we can navigate through different sections that will share different types of information about the file. In the general information output displayed when opening the file, we can see that the hash of the file in the form of SHA-256. The architecture type, in this case x64, the file type, and the signature of the language used to compile the executable, in this case .NET Framework that uses C# language. Okay, so this is what they're trying to illustrate to us here. So they've got the SHA-256 hash over here, okay, and we have the signature over here, which is Microsoft.NET, and we have the architecture, the CPU architecture, which is 64-bit over here. Okay, great, great. Let's focus on some critical data that we can obtain. First, if we want to identify the file and provide evidence of its alteration, we need to take note of the file's SHA-256 hash, as we mentioned above, as well as the hash of each section of the PE file. PE stands for Portable Executable, and it's the format in which Windows executables are arranged. You can learn more about it here, and they've got a little link. The sections represent a memory space with different content of the Windows executable within the PE format. We can calculate the hash of these sections in order to identify the executable properly. We'll focus this time on two hashes, the one from the .text section, which is the section on the file containing the executable code. This section is often marked as read and executable, so it should not have any alterations when the file is being copied. We can observe them in the screenshot below. Okay, so we're going to click on the footprints section over here. And from there, we've got our file hashes here, and we've got the section.text MD5 hash, which is this one over here. Another essential section that we can use to obtain information about the binary is the indicators section. This section tells us about potential indicators like URLs or other suspicious attributes of the binary. Okay, so indicators is located over here, so we're just going to click on that. And we're going to see the strings URL over here. And this seems to, let's resize this a little bit. Okay, and this seems to be to indicate some sort of URL. So we've got TryHackMe images, tryhackme.connect. Okay, and it's a PNG. All right. Let's see if we can squish this up a little bit. You can see more details. Okay, great. The screenshot above shows several strings on the file, like file names, URLs, and function names. This can be very important depending on the file's execution flow. Additionally, looking for artifacts such as IP addresses, URLs, and crypto wallets can be a quick win for gathering some identifying intelligence. We'll learn more about that in the next section. Now that we have information about the file we are investigating, let's try to understand what the executable is doing. We need to understand its flow. If we try to read the file by opening it, we cannot do it since it's in binary format. In the previous section, we learned that this file is compiled using .NET framework used by the C# language. We can decompile the binary code into C# using a decompilation tool like ilspy. This tool will decompile the code, providing us with readable information we can use to determine the flow of execution. Let's start by opening ilspy from the taskbar and clicking on the file open, and then navigate to C users administrator desktop demo. Select the file demo.exe. The tool ilspy may take up to 30 seconds to appear on the screen. Okay, so let's continue over here. So we're going to close PE Studio. So we're going to close it. And then we're going to start up ilspy from this shortcut over here. We're just going to wait a little bit for this to load up. Okay, so from here, we're going to go over to File, and then we're going to Open. And from here, we're going to go to Desktop, and then Demo, and then click on Demo, and then click on Open over here. Okay, all right, so that is done. So we can see here that that demo is going to be on, let's see if we can shift. Yeah, okay, so we definitely want more that we see on this side. And so we can access the demo file from the sidebar over here. Just click on that and make sure it's highlighted. As we can observe from the above, the left panel contains the libraries used by the framework, and the actual decompiled code is in the section with the file name demo. Let's click on it and expand it and see what it contains. Okay, so we can click on here to expand this demo, and then we see here metadata, references, and then a couple other things. And then we're going to click on the demo binary over here to expand this as well. And we see that there's a program in here. We can expand this. And we see a few more things over here. Base type, derived types, program, okay. and we're going to be exploring this program through these different nodes over here. As the screenshot above shows, ILSpy can provide much information, like the metadata and references. However, the actual show is displayed on the brackets symbols, and in this case, under demo binary program main, which is actually the main function of the executable. Now that we have access to the code running on the binary, let's analyze it. Okay, so we need to click on this right here. So under all of this, so it's going to be demo, and then demo binary, and then program, and then click on main over here. So just click on that, and then this is the code that we're looking at here. So this is, so we're going to be taking a look at the code in here because it's a little bit larger than the code in this window over here. Okay. So the above code displays the main function and its code. We can observe that first it prints the message to the screen, hello THM demo binary, using the console.writeLine method, okay, over here. And then it uses the sleep method to wait for 5 seconds, sleep 5,000. So these are milliseconds, so 5,000 milliseconds is 5 seconds. Then it assigns a value to two string variables, address and text. The first one with a URL containing accessing a PNG file, and the second one with the file name on the user's desktop named thmdemo.png. Okay, so string address, the address is equal to this URL over here, and then the text is going to be equal to thmdemo.png. Then we'll try to connect the URL on the address variable and save the content to a file on the desktop using the web client class. It will then execute the downloaded file path assigned to the text variable using the process class and the start method as displayed below. Okay, so these are the lines that detail all of that. Finally, it prints the message, bye-bye, leaving THM demo binary again to the console and waits for 5 seconds using the sleep method before closing. Okay, and these are the lines of code that do that. Great. We now understand what the binary is doing. It will download a PNG file to the user's desktop from the URL, this URL right here. Let's execute the file and see this happen. Once the binary starts, wait for the text hello THM demo binary to appear, then press enter to download the file. Okay, so note we are only executing this binary because we are in a sandbox environment. Execution of an unknown binary on a host is not recommended. All right, so let's do exactly what they instruct over here. We're going to click on we're going to double click on the demo binary here, and we should see hello THM demo binary, and then hit enter, and then it downloads the file, and then it shows us the PNG image over here. Okay, so we just ran the demo binary, and it does exactly what we expected it to do. It downloaded a PNG, and then it opened up the PNG, and so yeah, we figured it out. So let's get out of here, and let's start the second part of this exercise. So after executing the file, we can observe that it was downloaded to the desktop and the messages print to the screen as expected. Also, the downloaded file is executed and opened using the default app for PNG, which is Paint. Excellent. We successfully reverse engineered the flow of the code. Now that we have some practice, join McSkitty and help investigate the alerts coming from the file werevilleapp.exe. Put on your reverse engineering hat and help decipher the mystery behind this suspicious binary. Note, to answer this question, you will need to reverse the application werevilleapp.exe located on the desktop. Okay, so what we need to do is we need to get started and get set up. So we're gonna still be using ILSpy, but we're going to be investigating the Wereville app executable instead. So for here, we're just going to, I think we might be able to remove this. And yeah, so we're just going to remove the demo binary, and then we're going to go to File and then Open, and we're going to go to the desktop, and we're going to open up the Wareville app over here. So just click on it and then select Open over here. All right. So we need to get started. We need to take a look at the code. So what we're going to do is we're going to start expanding. We're going to start expanding this. So we're just going to click on it. And then we're going to click on Wareville app 1.000 over here. And then afterwards, we're going to click on Fancy app. So we're going to click on Fancy app over here. And from there, we're going to click on OK. All right, so the first question we have to do is we need to answer this question. So what is the function name that downloads and executes files in the Wareville app.exe? So what we're going to do is we're just going to in form 1, there's some types. So public form 1 and initialize component. And what happens in initialize component? Let's see. So initialize component. I think where we want to go is we want to go to form 1. Let me take a look at my notes. So fancy app and then form 1. And from form 1, we want to take a look at, let me expand this a little bit. So there's a certain function in here called download and execute file. So this is where we would find the function name that downloads and executes files. So go ahead and click on that. And we can see here that inside of the code, they've got an address that leads to some sort of URL, and the URL is over here. And what it does is that it downloads a file. So web client, download file, address, and text. So what is the name of this function over here? It's called download and execute file. So we just need to click here and use that as the answer. So it's download and execute file. So click on submit. Okay, and the next question is, once you execute the Wareville app.exe, it downloads another binary to the downloads folder. What is the name of the binary? So we can see here that it downloads to the downloads folder. So the downloads folder is here, and the name of the file that's going to be downloaded is called explorer.exe. So we can see that over here. And we also see that the name of the file that's downloaded is also called explorer.exe from this mayerc2.thm. So that's the answer. It is explorer.exe. Click on submit. Okay. So what domain name is the one from where the file is downloaded after running warevilleapp.exe? So we can see here that there is an address, and the domain name for this address is mayerc2.thm. So we're going to use that as the answer. mayerc2.t. I need to mayerc2.thm, and then click on submit. mayerc2 mayerc2. I gotta spell that correctly. THM. HM. Okay, click on submit. All right, so the next question is, the stage 2 binary is executed automatically and creates a zip file comprising the victim's computer data. What is the name of the zip file? So the stage 2 binary is actually not downloaded yet, so we need to download this file and take a look at it manually. So what we're going to do is we're just going to grab this file address and we're going to copy it. And then we're going to start up our web browser in this computer. So in the computer here, we're going to search for Microsoft Edge. So just go into the search bar, type EDGE, and eventually this is going to show us Microsoft Edge. So we're just going to click on this afterwards, and that's going to start up the web browser. So after that, we can set this as the default. Sure, why not? And just click out of here. And then it's going to start loading up. After it's fully loaded up, we can then paste in our web address and then download the file. So maybe we don't need to wait for it. We're just going to click into the address bar and paste in the address. After that, hit enter, and that's going to download the file. So we just need to wait for that for just a second. This is going to be, okay, so it's starting to download now. And it looks like it is it finished? I can't tell. But anyways, what we can do is we can open up the downloads folder. Okay, it looks like it's finished now. We're going to open up the downloads folder by clicking on this button here, just to make sure that it is here. Okay, so this file is here. We're going to import it into ILSpy. So we're just going to close the window, and we're going to close the Edge window as well. And then we're going to go to in ILSpy. We're going to go over to File. And actually, wait, before that, we're going to close out everything in the previous file over here. We can actually remove this because we're not going to be doing any more analysis on it. So on Wareville app, we're going to click on it, and then we're going to right click. We're going to select remove. Okay, so after we've done that, we can go back up to File and then Open. And we're going to go to our Downloads directory. So we're going to go over to Downloads, and then we're going to click on Explorer here, and then we're going to select Open. Okay, so after that, what do we need to answer? So the stage 2 binary is executed automatically and creates a zip file comprising the victim's computer data. What is the name of the zip file? So what we need to do is we need to do some exploration of this Explorer binary. So we're just going to click on the plus symbol in the Explorer here. And then we need to click on the File Collector tab over here. And then we need to click on the program. And let me take a look at where we need to go to take a look at this. So we need to go to File Collector Main. Okay. So the main function is over here. Just click on that. Okay. So we're told about some sort of zip file that's happening over here. So what this binary does is it collects a bunch of different files and then it zips them up into a zip file. So it looks for files like .docx, .pptx, .png, .gif, .jpeg, and then it's going to create a zip file out of them. So the name of the zip file we can find out by navigating down over here, and the name of the zip file is this one right here. It's called collectedfiles.zip. So that's the answer for the next question. So in here, we're going to answer collected files.zip, collected files.zip. Okay, submit that. Okay, great. And the last question is, what is the name of the C2 server where the stage 2 binary tries to upload files? So the very last thing that's going to happen to this collected files.zip file is it's going to be uploaded to a certain destination. So at the very end of this over here, it says upload file to server. Okay, so this is the name of a different function. So we can actually click on upload file to server, and this takes us to the function over here, upload file to server. This is the name of the function. So the address is going to be http anonymousc2.thm /upload. So this is the location to which the file is going to be uploaded. So what is the name of the C2 server? So it is anonymousc2.thm. So click over here, and the answer is anonymousc2.thm. Click on submit. All right, so that is it for this particular day for TryHackMe's Advent of Cyber 2024. And the last thing we need to do to complete the room is click on this over here. If you enjoyed this task, feel free to check out the x86 Assembly Crash Course room. Okay, so with that said, we just need to click on this button over here. And after we do that, we see that the entire task turns green, which means we have finished the task. Great. All right, so that was a guided walkthrough for day number 21 of TryHackMe's Advent of Cyber 2024 event. If you enjoyed this walkthrough, please click on the like and subscribe buttons on the video. But until then, HackerFrogs out.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.